Okay. So it's 7 o'clock. We do have a number of folks that have joined us, but I think we'll go ahead and get started, and others can certainly join in as we get underway here. So my name is Jen Helpy Ferguson. I am with the Canadian Red Cross and also a member of our ShakeOut committee and BC Earthquake Alliance, and it's my pleasure to welcome you here tonight. Really excited to have this conversation with our panelists. We've got our friends from Natural Resources Canada, so I'm going to introduce them first. So Alison, if you want to give a little wave there, Dr. John Cassidy, and Andrew Schaeffer. All three are seismologists from Natural Resources Canada and are really going to bring the science to the table here tonight. And then, of course, we have our friends and partners and actual sponsors of ShakeOut, Michelle Petrusevich. Hope I said that right, Michelle. Okay, and she's from Fortis, BC. And then we have Marc Spencer, and he is from BC Hydro. So really good cross-section of information we're going to share here tonight about really how to be safe when the earth shakes. That's really the message here today. And we're going to talk a little bit about the science. But before we get underway, I do want to just make mention of the fact I'm coming to you tonight from Nanaimo, the traditional territory of the Nanaimo people, and of course the Coast Salish people. And we're all grateful to be here in British Columbia and living and working on traditional and unceded territory. So thank you to our Indigenous partners and communities for allowing us to do that and be here today. Okay, so a little bit of housekeeping. I made mention of the Q&A a few moments ago, but if you're just joining us, please take advantage of that. Take advantage of the chat box. If you have questions, you are more than welcome to pop in your questions there. I'll be moderating the chat. You also can tweet us your questions to @ShakeOutBC. And my colleague Danielle from the Canadian Red Cross is going to be monitoring that, and she's going to send them over to me tonight through technology. You gotta love it. So we'll make sure we get your questions answered. Now's your opportunity to ask any of those burning earthquake questions or safety questions that you have. So without further ado, I think we're gonna start with our seismologists and talk a little bit about the region that we're in. British Columbia is a seismically active region. I think we all are aware of that. And so I'm interested, John and Andrew and Michelle, how many earthquakes do we experience every year?
I think you meant Alison.
Oh, sorry, Alison. Oh my goodness, Alison. Yes, thank you.
That's okay. I'll answer this one just because I was most recently actually locating the earthquakes that we record. In terms of British Columbia, we locate, using the data that we retrieve, about 3,500 earthquakes every year. About 900 of those are in the Vancouver Island area. We record many more than that. Sometimes they're just too far away from our senses to get a reliable reading, or too noisy, and so we don't get those. But you know, we have earthquakes every day, in other words.
And so when you say we don't feel them, what kind of size are we talking about, or what kind of magnitude are we talking about in some of those smaller quakes? What are your instruments recording?
Well, it depends on how close you are to the earthquake to how likely you're going to feel it, not just the magnitude. So generally speaking, if you have a magnitude 3 right under a town, people in that town will feel it. But often we don't get people feeling earthquakes until magnitude 4 or 5, just because they tend to be a little further away from those events, or the event tends to be deep. And then those seismic waves have to come up through that material to reach us. And in that time, they're weakening and the energy is dissipating, so the shaking is not as strong at the surface where the people are.
Where the people are, I like that. Where have the largest earthquakes in British Columbia occurred? Where do they traditionally occur?
I'll jump in. The largest earthquakes and the most frequent earthquakes, both here in British Columbia and in fact in all of Canada, occur off the coast. And so this is where the active plate boundaries, where these giant tectonic plates that make up the surface of the earth, where they meet. So we live here, we're on North America, the North American plate, but just offshore is the Pacific plate. And off of Vancouver Island, between the Pacific plate and the North American plate, are a series of small and very young ocean plates, the Juan de Fuca, the Explorer, the Gorda. And those plates are in movement. They're moving at about the same speed that your fingernails grow. So that's what causes the earthquakes, the volcanoes in this region. And it's the movement of those plates that cause the earthquakes. And so the biggest earthquakes in the world occur right on these boundaries where these tectonic plates meet. So in the magnitude 8, magnitude 9 range.
So, and I think that's, go ahead, Alison.
I was just going to say, to follow on from that, I mean, we've got two different types of plate boundaries right off our coastline. And along the west coast of Haida Gwaii, we've got a dominantly strike-slip fault. So this is side-by-side motion, where it's very similar to the San Andreas fault in California. We've had major earthquakes, the largest instrumentally recorded earthquakes in Canada, 8.1 in 1949, for instance, and there was a 7.8 also in 2012. And then off Vancouver Island, as John mentioned, there's this subduction zone where you've got the Juan de Fuca plate pressing beneath us, and that subduction zone goes from Vancouver Island down into Northern California. And subduction zones where you get the largest earthquakes in the world, these mega thrust earthquakes, and they're, you know, pretty dramatic events.
And I think that's what, you know, when we think about, and I'm going to use air quotes here, when we think about the big one, I mean, that's what we're talking about, right? We're talking about these mega thrust earthquakes. Can you just talk a little bit about that Cascadia subduction zone and sort of the risk or what we might experience with one of those very major earthquake events?
Well, they're huge. Of course, the shaking is quite significant, and it lasts a long time. The larger the earthquake, also the longer the shaking goes on. And so we can expect shaking for 3 to 5 minutes, which will seem like a lot longer if you're going through it because it's such an unusual experience. And the shaking from these can be felt quite far. You know, of course, the further away you are, the less severe the shaking, but you still might feel some swaying. In fact, people possibly as far as Toronto might experience this event. I mean, it's really quite incredible. And then, of course, because it's a megathrust earthquake and it's in this sort of ocean setting where there's a big vertical movement of the ocean floor, they, of course, also trigger tsunami. So they're doubly threatening.
And I think that's an important point as well, is that, you know, not every earthquake will generate a tsunami. So maybe you can speak to that a little bit. Or John.
No, I don't want to hog the limelight.
Yeah, I can take that one. Yeah. So
Please.
The tsunamis are, of course, created, as Alison and John have said, by these large megathrust subduction earthquakes, where essentially the surface or the sea floor moves in response to the earthquake. But the strike-slip type of earthquakes, so these are these sideways motion earthquakes, which we get in a number of locations across Canada. And in BC, for example, the Queen Charlotte Fault has a fairly strong strike-slip component. So some earthquakes along these strike-slip boundaries actually pose no sort of tsunami risk. The Queen Charlotte Fault actually does have some convergent components. So for example, the 2012 earthquake did produce a tsunami, the largest tsunami of that year. But some of the other faults that lie off the coast, for example, John was talking about these plates that lie just off the BC coast, the Explorer, the Juan de Fuca, and the Gorda. There's boundaries between those plates themselves, and those faults are strike-slip faults. Some of the most active faults that we have actually are those smaller faults off the coast. And the earthquakes that happen there essentially don't produce tsunamis. The earthquakes are quite small, but they're also the type of earthquake that wouldn't produce offsets in the seafloor.
I think the interesting thing about tsunamis, and certainly for those of us that live, you know, in coastal areas, many of us do, is we can't tell the difference when an earthquake is happening, whether it's going to generate a tsunami or not. And so I think, you know, just ensuring that preparedness, ensuring we have a plan, we want to make sure that we highlight that here today. And, you know, that ground shaking is your tsunami warning. So if you feel an earthquake, you need to move to high ground. So I do want to make sure we reiterate that. You know, you're not going to be able to tell the difference. So please do make sure that you're making that move. I want to come back to something else, you know, Alison, and I think Andrew, I think all three of you have now highlighted this, and that is, you know, these different types of quakes that we have, whether it's a strike slip quake, whether it's a, you know, a subduction quake, there's this perception, I think, when we have these smaller earthquake events, and John, you were tweeting today about ETS quakes, and, you know, might we be entering the slip? So I'm going to let you talk to that in a minute. But first I want to ask, we have these smaller quakes. I think there's a common perception out there that this means that we're relieving the pressure in the zone, and that will reduce the likelihood of having a major quake. Who would like to tackle that one?
I was doing some math on that earlier today, Jen. If we take the magnitude 9 earthquake as an example, the big subduction earthquake that happens every roughly 500 years, plus or minus a few hundred years. And we take a magnitude 3 earthquake, which is sort of the limit of where you would start to feel shaking typically. It would take, because the energy released by earthquakes increases so quickly as a function of magnitude. If you go from a 3 to a 4, there's 32 times more energy released. And if you go to a 5, there's now 1,000 times. So if you do the calculation, a magnitude 9 earthquake releases 1.1, the energy equivalent of 1.1 billion magnitude 3 earthquakes, which over 500 years would be about 6,000 magnitude 3 earthquakes each year along this fault zone that we know ruptures every 500 years. So, we're not seeing anything like that. These tiny earthquakes that we see are really so small. They just aren't, they're really just a drop in the bucket compared to the really big magnitude 8s and magnitude 9 earthquakes. So tiny. These small earthquakes that we see daily are not releasing anywhere near the energy that we know will be released during these large earthquakes.
Yeah, plus they aren't happening on the subduction interface, so they're actually not releasing stress in that area.
They're not in the right spot.
No, they're not. They're most of them are happening in the North America plate, which is the one we're living on, or within that subducting Wanda-Fuca plate as it bends and goes down into the mantle.
And we can compare this to some other subduction zones around the world. For example, Japan, where they have quite a large number of earthquakes, on a weekly basis that people feel, and they still have these large magnitude events. Whereas Cascadia, it's a relatively quiet subduction zone compared to some others.
I think that restating that, those smaller quakes can't release enough energy to offset what would be the equivalent of sort of that big one, as we refer to it here sort of locally. I want to come back, John, to your, you've been tweeting the last couple of days, well, Andrew said it's been seismically quiet. I don't believe him, because you've been tweeting about ETS and, more increasing tremors here on the coast. So tell us what's going on. Are we entering the slip?
We're both correct. There have been about, I think, 3,000 tremors, more than 3,000 tremors, but these are not earthquakes. So these are, vibrations that are being generated beneath the surface, probably close to that boundary where the ocean plate is being pushed beneath North America. So this started about nine or 10 days ago now, and we've seen thousands of these very tiny tremors, but they're not earthquakes. But they are associated with this phenomena called episodic tremor and slip, when Vancouver Island and parts of Washington, Oregon, and California, which are normally on a day-to-day basis, we're normally we're being pushed very, very slowly to the northeast. So Vancouver Island is moving to the northeast about 1 centimeter each and every year. And during this ETS event, we suddenly change direction and move back towards the Pacific Ocean, 3 or 4 or 5 millimeters. So it's a small fraction of what we do during the year in terms of moving towards the mainland. But it's this back and forth motion that was discovered about 20 years ago. It's quite an amazing phenomenon. It's not just here, it's in subduction zones around the world and even on other types of faults like the San Andreas fault. But it's telling us that, first, it reminds us this is an active subduction zone. because that's where you see these tremors and slip. But scientifically, it's very important. It's been helping us to map out the subduction zone and where the faults are, where the fault is locked, where it's not locked, and that region between where the plate is just slipping freely and where it's totally locked. It's telling us something about about our subduction zone that we can use to better assess earthquake hazards.
And add some numbers. Oh, sorry. Just add some numbers to what John said. So I'm just looking at the tremor database right now. And so since October 1st, there's been 5,421 located tremors. So
that's amazing. I love that you have a tremor database. That makes me, as I'm a nerd, and I love that there is a tremor database, and you all can just look that up and tell me there's been 5,000 earthquakes in the last 14 days. That's unreal. I love it. Thank you for that, Andrew. That's amazing. We had a question from Jocelyn, and she's wondering if there was an earthquake, where people could tune in to find out if a tsunami has been generated, and therefore if they need to seek higher ground.
Well, you should, if you feel an earthquake that's really strong, so it's hard to stand, or the shaking lasts more than a minute, anything like that, that is strong enough that it could have generated a tsunami, and you need to get to high ground right away. Don't wait to find out, because you're losing precious time there. So you get to high ground, and then find out later on, usually because you have a radio or your phone or whatever with you. There's the National Tsunami Warning Center, which monitors the North American coastline, and it will alert you to whether there has been a tsunami generated. But it really is best to take that action right away. And if there's no tsunami generated, you went for a hike and you didn't need to. But if you don't go, there's a big chance you'll be caught up in something that's really quite threatening. And this is something I'd like to mention, because it's sort of tied in. The tsunamis are more than one wave. There's a series of waves that come in and out, and they take a long time to come in and out, sometimes half an hour to an hour each wave. It's not at all like a tide or anything like that, or these other little waves you see. There's a lot of power behind them, because there's a huge mass of water behind them. So even a low tsunami wave can knock you off your feet. And the other thing is that the first wave is usually not the highest. It's often the second, the third, the fourth wave, which is much higher than the first. So stay evacuated for some time until you are certain that it's safe to come back down.
I think the other important piece there, and to Jocelyn, is I'll just say that Twitter is your best source of information, typically in an urgent situation. So as Alison said, the National Tsunami Warning System, they're on Twitter. We will also see information come out from Emergency Info BC. Usually that comes out very quickly, but the National Tsunami Warning System is usually first. And local authorities. So depending on where you are on the coast. So for example, in Tofino and Ucluelet, they do have tsunami warning sirens, and you will hear those. But you still, want to make your move, and as soon as the ground stops shaking, and make your move inland, and up, not just inland, but also up. And you want to so Twitter is your best source of information. So local authorities will be communicating that information out as well. But excellent question. Okay, so maybe we're going to change gears here a little bit, and I want to come back to Andrew. Since COVID, we've all been doing things a little differently. I mean, this virtual setting tonight for an earthquake talk is something that's a little different. It's how we roll in 2020. But you were studying a little bit about seismic noise. So maybe you could just share with us a little bit of the research that you've been doing and what you've been learning since we've all been working from home.
Certainly, yeah. So, the conversation about tonight is really all about earthquakes, and they get all the glamour. But, the instruments that we sit out and record with that are out in various places across the country, they are recording every little ground vibration that passes by. And when we talk about ground vibrations, we're talking about things that are, micrometers in size. So things that we would never feel, anything like that, they're picking up those vibrations. And those vibrations are caused by a whole host of phenomena. They include natural earth processes. They can be very, very small earthquakes, but they can also be caused by other things like wind blowing through trees. And as the trees rock back and forth, their connection with the ground causes little vibrations that the instruments pick up. waves and the interface between the continent and the ocean is one of the largest sources of what we call seismic noise. And the term noise really just refers to the fact that it's blocking the earthquakes or signals that we want to see. But there's a lot of information embedded in it, and seismic noise is actually an entire field of seismology on its own. But in this time of COVID and lockdown measures, what happened actually was a lot of people scientists and hobbyists started to look at seismometers, and they saw, if you looked at the average noise recorded at a seismogram over, hour periods and plotted as a function of time, you can actually see the lockdown measures take place in the background seismic noise. So this is ignoring things like earthquakes and real seismic activity. This is just looking at the Earth's hum, so to speak. And what we see is that the volume goes down as we all get locked in our homes. You can correlate this with, in southern Vancouver Island and a lot of BC, it was right around that March 16th, 17th, you can see the seismic noise drop. Now, one thing that's really interesting with this is that, when we go and put out our scientific instruments, we don't put them in cities precisely because it's too noisy. Most of the instruments, the scientific grade instruments, are actually located in remote places where they're not affected by this noise. So you don't see any of this lockdown signal on them. But there's a number of more hobbyist type instruments that are deployed in cities. And John, Alison, and myself each have one running in our houses. And in cities, you quite often pick up this stark decrease in noise by a factor of 2 drop in background noise. And this is essentially reflecting way fewer cars on the road, construction came to a stop, this sort of thing. That said, the instrument in my house and the instrument in Alison's house, the noise went up when we got locked at home. And of course, that's because we're at home making noise in our houses. So it was a very, very interesting phenomenon that quickly gained some traction around the world with looking at this sort of reduction in seismic noise, which goes along hand in hand with, the decreases in pollution seen in some places like this.
Well, and that change, we're not traveling, we're not moving in the same ways that we once were, really restricted movement in many communities as well. So interesting, it'll be interesting to see how we progress over the next, let's say 6 months, because we've been in it now for 6 months, and see how things shift. So in the spring, we're going to do this again, Andrew, and you can report back as to how things are going.
I can tell you already that it's mostly returned to normal. We're not quite back because as the lockdown measures have been loosened, we're not all locked in our houses quite the same way. So, if you're out driving, you probably feel like there's almost the same amount of traffic again, that sort of thing. So it's not quite back to where it was in, say, February, but it's getting pretty close. In most
we've got a question here in the Q&A for you, Andrew, about seismic noise. And tuning out the Earth's hum, or as Garrett calls it, the human hum, which I like that term. He's wondering if there's been any interesting efforts lately in applying pattern recognition technology to allow us to better isolate genuine earthquakes and tremors from seismic noise. Yeah,
it's actually a diverse field applying these sorts of, there's machine learning techniques, there's template matching, there's a variety of ways. Training neural networks, for example, with hand-picked data sets. There's a variety of ways that are employed, mostly in the research community, to try to distinguish between noise and events. And really what it comes down to is how dense your observation network is. It has a lot of control over how well you can distinguish between noise and an event. And also what your definition of an event would be, if it's purely a tectonic earthquake or if you're looking for some other sort of signal. But yeah, it's a very large and very fascinating field. There's a lot of active work in it. It doesn't tend to be employed quite so much for national catalog generation, for example, because those are using more stable, more robust techniques.
Excellent. Okay, lots of good questions coming in here. So I'm gonna do one more, and then we're gonna shift over to Michelle and Marc. But I think John and Alison, I'm gonna look to you for this one. Why do you think these tremors and clockwise rotation is mainly in Oregon and Washington and doesn't really go into or stops almost at the border? And I think maybe that's referring to, this is Greg's question, I think maybe he's looking at the map, John, that you posted recently where it showed the ETS was really heavily dotted southern Vancouver Island and sort of Puget Sound. I think that's where he's going there.
Sure. So, I mean, there is a clockwise rotation that's observed in Oregon and Washington that we don't see so much here in British Columbia, and that's a result of the plates and the North American plates from spreading, where it's sort of pulling apart in the Utah, the Great Basin of the Western US. The plates are actually sort of stretching and causing this rotation that we can see from GPS data. So the surface of the Earth is rotating through Washington and Oregon. But the tremors, they tend to form a very narrow band that run parallel to the subduction zone. So they run parallel to the coast, all the way from California, as Alison mentioned, where the subduction zone begins in Northern California, Cape Mendocino, all the way up to around the Brooks Peninsula of Vancouver Island. So it's a relatively narrow band and just runs right along the coastline. And that's where these tiny tremors occur. So why they're there is still being looked at. It's likely that it could be related to fluids, the pressure, temperature conditions. It's just the right setting to create these tremors. So there's still a lot of questions, still a lot of research underway looking at these events.
And if I can add a quick point to John.
Sure.
That picture that John tweeted, I guess it was earlier today, was just, I think, a snapshot of either yesterday or today.
Right.
And so there's a gap along the border there. But if you look at where these tremors occur over a long period of time, there's no gap on the border. As John said, it's continuous right from just below the Brooks Range all the way down to northern California. The one gap that there is actually around Corvallis, between Corvallis and Eugene. In Oregon, and there is a small gap there. Well, not a gap. There's still events, but not quite as many.
So earthquakes, like tourists, don't see the geographic boundary between regions. That's what I'm hearing you say. Okay, let's shift gears here a little bit. We've still got some good questions coming in around earthquakes and some of the big things. We're going to come back to those. So we're going to come back to Alison, John, and Andrew. We're going to shift gears here and invite Michelle and Marc to put their cameras back on, and we're going to put them on the hot seat here. So just as a reminder, Michelle is with Fortis, and Marc is with BC Hydro. And so we've got a few questions here that have come in for them. So Michelle, I'm going to start with you. What are some of the ways that we can prepare our homes and secure natural gas appliances and just to be better ready for an earthquake?
Well, thank you for that question. I think preparation is a really important step, as what John and Andrew and Alison pointed out. There's a lot of science that's happening, but I think the key message for this is being prepared. And one of the reasons ShakeOut happens for us, for everybody once a year, is because we want to develop that muscle memory and to know what to do during an earthquake. But there's a lot of other things you could do. So simple things like having your emergency preparedness kit ready. If you don't have one ready, consider assembling one. It doesn't take that much effort. There's lots of helpful YouTube videos that you could look at. But as far as preparing your home, when you do an annual inspection of your gas appliances, make sure that those are up to code. Make sure that your water heater, for example, has straps to it. It is now code. So if you have an older one, ask your gas fitter to make sure that it does do that. So, and the reason we ask for it is in case of an earthquake, things can shift in your house, and you don't want to lose that source of water in your house, and a water tank does contain a lot of water, and you want to make sure that it's there and it's attached to the wall. And then same goes for the gas appliances as well. Make sure that they have a flexible hose to them. I was actually trying to Google some pictures what they look like, but they just look like a flexible hose. That's all it is. And ask your contractor, your gas fitter, to make sure that that's what I have, to have those things. It doesn't cost that much money. It's part of your annual check. You should be checking your appliances just like you check your car on regular basis, and same with the appliances.
Thanks, Michelle. I think that water tank comment is such an important one. You know, they tend to be in the basement or sometimes in the garage, and they're sort of out of sight, out of mind. We don't think about it until we run out of hot water, right? And so I think that, you know, just really thinking about securing that and recognizing that it is a potable sort of source of water. So in the event of an emergency, it's something that we can access. Super great tips. We actually just recently secured our gas stove. We had a gas stove installed, and it was the same kind of thing. Let's make sure that this is going to be safe. Marc, let's talk a little bit about hydro. So we, of course, in the South Coast, we experienced, you know, a windstorm, and we're sort of used to seeing, you know, sometimes a day or a few hours anyway without power. But in an earthquake, that could look a lot different. So we may see a sustained power outage. Can you just talk a little bit about what that might look like?
Yeah, absolutely, Jen. Thanks for the question. And we expect windstorms every year. So every year, this time of the year, we'll have a windstorm or two, or sometimes more than that, and we're ready for it. So we expect it. We have a full complement of crews available to us when we know that when we anticipate that windstorm coming down the road. We generally know a day or two in advance. We'll muster our crews in strategic areas. Sometimes we'll call on crews from up north, bring them all the way down to the lower mainland or to Vancouver Island, and have them ready for it. When an earthquake happens, we don't have that luxury. So the 1 hour, 5 hours, 1 or 2 days maybe that you might expect to see in a windstorm gets extended. So we would expect that there's a possibility that an earthquake could cause a very large extended outage. To Michelle's point, which is fantastic, we recommend people have that 72-hour emergency preparedness kit, and that should set you up for success. Also, that would include enough food and provisions for every member of your family for about 72 hours. And thinking back, we had that windstorm on the Gulf Islands and on Vancouver Island a year and a half ago, almost 2 years ago now. And some of those people were out of power for 8 days. And that was a hardship. There was some compromises, I think, that people made in terms of their safety. And it really scares me when I see that sort of thing happening, because people were stuck in their homes and they couldn't get out of their driveways because of down lines or other things. And so the message around that is very clear to stay away from our down lines as well. And to, when you see a down line, recognize that it's a danger and dial 911 to ensure an emergency response.
I think that's really important. I happen to be in Nanaimo, and I was 5 days without power. And of course, from a Red Cross perspective, we were responding to individuals and families who saw sustained power outage 5, 6, 7 days. Many of us, myself included, now I have a 14-day kit at home. And really that's so that I can help others, right? So I think that's an important message too. If you're prepared and you can look after yourself and your family, then you can go to your elderly neighbor and offer to provide assistance because you're prepared. And so I think, we can start to look after one another if we are prepared in our own home. But the danger around downed lines and that is an emergency and that warrants a 911 call is important. In an earthquake, it may be more challenging to make those 911 calls. So we want to make sure that, people recognize that that's a danger and that we're staying well back. Michelle, right. I'm gonna come back over to Michelle here and ask, might we see outages of gas during an earthquake? And if I need to leave my home, hopefully I could stay in my home even if it was damaged, but if I had to leave my home, should I turn the gas off before I leave my home?
Thank you, Jen. That's a good question, and that's a question that we get asked very commonly. So in case of an outage, first of all, our system is designed to withhold to an earthquake. Most of our lines in the Lower Mainland and elsewhere, they are out of it's a polyethylene. It's a plastic pipe that's designed to withhold earthquakes. But if there is an outage, or if there is an evacuation order, do not turn off your natural gas unless only if you smell or hear gas, or if fire emergency officials what happens is they would request Fortis BC to turn it off, and then our crews will do that. And you also would, the reason you don't want to turn it off is because if once you do, then you would need a technician to come back in and relight it for you. And if once you do, you won't have source of heat for until it's back on.
And one of the thanks, Michelle. I think that's great information. I think that's a very common question, you know, and when we see it also, for example, during wildfires and floods, where people are, you know, should I turn it off? Should I not turn it off? So I think that those are, you know, we're looking to local authorities or, you know, the fire department to provide that direction, as opposed to individual homeowners needing to make that decision. Marc, I want to come back to you and just sort of talk about, you know, we may see a sustained power outage. I mean, that's reasonable. We've talked about that, you know, in an earthquake. Is it safe to assume that the power line is dead if the power has been out for an extended period of time? Like if I come home?
And the answer to that is absolutely never. You never assume that a power line is de-energized. So there's a couple of reasons for that. We have fuses, we have circuit breakers, we have all sorts of mechanical devices intended to turn power off under certain circumstances. But if those devices don't work correctly or as intended, or if we put the power back on for whatever reason, trying to get people's power back on, we might not be aware of a certain problem in a certain location while we're trying to get people's power back on. Another issue is we might be restoring power to a hospital or to an essential service. We don't necessarily know about every problem at every moment. We definitely tell people, do not approach a down line, stay back 10 meters. One thing to keep in mind as well is that nowadays a lot of people have portable generators, and a portable generator will, if it's not hooked up by CSA standards and under the proper permitting by Technical Safety BC, will backfeed, or has the potential to backfeed onto the BC hydro system, well beyond our control, but definitely a hazard to anyone who's approaching down lines.
That's such an important point. So many of us do have generators, or might have generators in our home or at our business, for example. So I think that's a super important point. Thank you. We've got a question, Marc, that came in for you in the chat here, and hopefully you'll know the answer to this one. We'll put you on the spot here. What percentage of power is generated on Vancouver Island versus transmitted from the mainland? And might it be event specific, but there is a possibility of a longer delay in service restoration on the island? So it sounds like, I think the question is, should we expect to be without power for a sustained period of time on the island because we're on the island relative to the mainland if there was a significant seismic event?
So I apologize, because I was going to do some research on that. I know it used to be that Vancouver Island was not self-sustainable, and it was due to industry, I believe. I don't know where Vancouver Island is at right now, but I will say that in the event of an earthquake, we could have disruptions to our power, to our transmission lines. And transmission lines are the big grid that connects all the substations together. They come from the generating stations, from other substations, and connect them all together. If there's disruptions to those power lines, to the transmission lines, there could be sustained outages. Vancouver Island is connected to the Lower Mainland through a series of transmission lines underwater. And so it's a pretty robust system. But having said that, I'm not 100% on whether it's fully self-sustained or not.
Good. That's it's an interesting question. Michelle, do you want to jump in there?
Yeah, just wanted to jump in. Same for Fortis BC. There is we do have a transmission line that runs from Powell River through. It's the shortest connection actually, and it goes to Comox but we also have an LNG station that has LNG in it, and so in case of outages and might not, that we could then convert LNG back into natural gas.
Interesting. So I mean, it's good, and I think it's really great to hear, you know, BC Hydro and Fortis are thinking about these things. You know, there are emergency plans and contingency plans in place, and you work very often, both of you or both of your organizations work in these high pressure situations when we're having, you know, whether it's an earthquake or whether it's, you know, a wildfire or a flood or a windstorm, that we have to be thinking about these sorts of things all the time. So thank you both so much for being here. We're going to shift back to Andrew and Alison and John. And so stay tuned. We may still have some more questions, so we may come back to you yet. Thanks to you both. Okay. We've got lots of questions for our seismologists here. Are y'all ready?
Yeah.
Okay. Alison's like, bring it on. I like it. Okay. So one of the questions is, can you talk about the last large Cascadia megathrust subduction zone earthquake that was on January 26, 1700? And were there any warning signs? And of course, John, using his crystal ball, what is the time frame for the next big one?
Oh, well, okay. The crystal ball is fuzzy. We can't predict earthquakes, but we know that these big magnitude 9s, like the one that struck on January the 26th of the year 1700, that they occur hundreds of years apart. The minimum is roughly 250 years. The longest is in the order of 850 or 1,000 years. So they're rare events. They don't happen on a regular basis. So we can't say every 500 years or every 400 years. They are really quite irregular. There appear to be clusters in time where they may be closer together, 300 or 400 years apart, and then a stretch where it's 900 years or 850 years. So they're really quite, but they're hundreds of years apart. The likelihood of one of those events in the next 50 years is roughly, again, with really big uncertainties, but roughly 10% in 50 years. That's the best estimate. So they're rare events.
But still significant.
Very
still significant risk. Mm-hmm.
And we know the date and time of the last one from records in Japan. We have indigenous oral traditions here on Vancouver Island that clearly describe that earthquake in 1700 in terms of landslides and tsunami and strong shaking and aftershocks. So there's a lot of information. We don't know if there was any sort of precursor, any warning signs before it happened, but certainly the indigenous oral traditions all describe exactly what we would expect from that earthquake 320 years ago.
I think you make a good point there, John, around well, certainly the indigenous tradition and sort of that storytelling that continues. And I know in parts of Haida Gwaii, what you see are drawings on telephone poles, and that is the indigenous way of sharing. This is a tsunami zone, and what to do if something like that should occur. So really interesting ways of sharing information. But the other piece that I think was interesting, what you said there was, and we've talked about tsunamis and we've certainly talked about earthquakes, we haven't talked about landslides. And so we sometimes see these compounding effects or subsequent emergencies, if you want to call them that. So maybe you want to just speak to that a little bit.
Sure.
Alison or Andrew?
Sure, I'll turn it over to Alison or Andrew.
Sure. I mean, landslides are very, very common after earthquakes. After the Haida Gwaii event in 2012, there were innumerable landslides from that earthquake. They often get triggered. And some of those landslides, if they're along the coast or underwater, they can actually trigger their own little localized tsunami. So this is why we say any large event, if it's really strong shaking, you should get to high ground, just because we're not sure if it created a tsunami or not. It's hard to tell right away. You can also have other hazards triggered, like liquefaction. So this is like when you go down to the beach and tide's been out for a while, it's quite firm. But if you stand in one place and you temp your feet up and down, all of a sudden your feet start to sink and it goes kind of like quicksand around them. This is liquefaction on a small scale. In a large earthquake, if you have sandy soils where there's quite a bit of fluid in them, they can become like this liquefied sand for a little while. And all of a sudden they're not supporting the roadways properly. They can crack and bend, and you can actually have these sand boils come up, and buildings might not be supported properly anymore. They might tilt a little bit or sink a bit. So it's there are these associated hazards. I mean, it's very rare you have an earthquake that's just an earthquake and only causes a certain amount of damage. It's, there are often these other landslides, liquefaction, tsunami that can happen as well. And then you can throw in some bad weather.
Right? And in the winter or something like that. Well, yeah. and we saw liquefaction, quite significant liquefaction in Indonesia. We've seen that occur where, there's videos of, things sort of sliding by and it's, the ground has liquefied. And also during the Christchurch earthquakes, Alison, you and I were chatting about that the other day. Yeah. So, I think those are very recent, tangible examples of liquefaction. I don't think it's what comes to mind for most people. So I don't know if you want to highlight a little bit out of learnings out of Christchurch.
Well, Christchurch was a huge learning experience for us because Christchurch is very, very similar to Victoria. It's got about the same population, geography, building code, population, industry. It's really like a really good proxy for what we could expect. And they had neighborhoods where there was quite a significant liquefaction. There are a lot of pretty interesting pictures of cars sort of nose diving into the ground because, of course, the engine compartment of the car is very heavy, so that's going to go. That's the part that sinks. So yeah, they had a lot of damaged roadways. A lot of those neighborhoods are now being turned into parkland because it's been decided it's that's not somewhere that we should really have people living. And it, that earthquake was a good learning experience for us. I mean, what types of damage, how long it takes to recover from this sort of thing. I mean, this is not something where you can push a button and everything's rebuilt. I mean, and when you do rebuild, you want to, as they say, build back better. You want to build to superior code. You want to make sure that this you can be a little bit more resilient the next time around.
I think the build back better is interesting, and this sort of ties into one of the questions that's come in, and that is, if the big one hits along the coast, how much might it affect the southern interior, or perhaps you could say other parts of British Columbia? And how soon can that earthquake be made public? So when might people know that an earthquake has occurred?
Well, they feel it. But let me come back to that in a minute. I'll put a little pin in there. In terms of the interior and other parts of BC that are further away from the coastline, they would feel this sort of longer period undulating movement rather than the high frequency jiggling, shaking that you feel when you're close to an earthquake. So those undulations, they often make people feel motion sick. In fact, First Nations who are on the mainland during the last megathrust in 1700, they talk about people, vomiting, being sick from this earthquake. And I felt that myself when I was up on Haida Gwaii. I felt an aftershock. I was far enough away from it that I just felt this really long period, sort of circular motion, and I felt very woozy. I did not enjoy that experience. So that's the sort of thing. They might have like things swaying. They probably won't have structural damage, but things might fall off shelves, and that sort of thing could happen. In terms of warnings, we don't yet have that ability, but I just joined a team, and we are developing an earthquake early warning system for Canada. And we're starting in areas where the risk is highest, so the coastal areas of BC. Specifically, we're starting in southwestern BC, but going up the coastline too. And the idea behind that is, I'm sorry, I'm going to geek out a little bit here, but there are two main waves that propagate from an earthquake. There's the P wave, which is the primary or pressure wave. That's the initial jolt or rumbling that you experience from an earthquake. And then there's an S wave. That's the secondary or shear wave. It's slower, but it's more dramatic. You get that big side-to-side motion. That's the one that causes the most damage in earthquakes. The idea is these P waves propagate out from the earthquake. they hit our sensors that we will be installing that are specifically for earthquake early warning. The sensors send data to the data centers, and the data centers send an alert out. And the idea is that you receive the alert before the arrival of the strong S waves. Of course, this is only giving you a few seconds to maybe tens of seconds of notice. So this is not an evacuation alert. It's not, you know, like this is not prediction. This is just telling you, look, an earthquake's just happened. Quickly take it back to evasive maneuvers or evasive action. And you have things like, you know, tomorrow's drop, cover, hold down drill. This is what you should be doing. This is why we want you to practice it, so that's what you do if you get this alert. When it goes to other organizations, like it can trigger automated responses, such as opening fire bay and ambulance bay doors so that those emergency vehicles can get out, stopping traffic from going onto bridges or into tunnels, telling surgeons in a hospital to stop surgery, parking hard drives, moving elevators to the nearest floor and opening the doors. There are so many things you can do with just a few seconds notice. And of course, there will, you know, it's not infallible, this system. I mean, there will always be an area close to the earthquake's epicenter whereby you're too close. It's just not possible that we can get you an alert in time. But for the rest of the area, you can get those valuable few seconds, and that can make things a lot safer. And it's just tying into the building code, our preparedness, our drop, cover, hold on drill. This is the final, you know, not final piece. This is another piece that's going to make us as a community more resilient to earthquakes.
And I think you talked a little bit about muscle memory and sort of that, you know, drop, cover, and hold on. And that's, you know, really what ShakeOut is about tomorrow is, you know, dive under your desk or get under a table, you know, hold on. And it just is creating that instinct. We know exactly what we need to do. Just like when we hear a fire alarm, we know we need to leave the building. This is the same kind of alert system, right? It's that trigger to seek safety. Maybe I'm going to ask the three of you as well, from a Natural Resources Canada perspective. You can talk a little bit about sort of the role of NRCan and some of the ways that you're mitigating risks, like through building codes and, you know, obviously early alert systems. And what else have you got cooking over there? Lots of things.
Oh, goodness. Well, maybe John should go, or Andrew, do you want to go?
Hey, John, why don't you go?
Sure. I mean, the basic earthquake research that we do feeds directly into our National Building Code, into our earthquake hazard model that is then used in our National Building Codes, used in bridge codes, dam codes, used across the board. So these are updated every 5 years. So the work that we're doing, studying the small earthquakes and how the waves propagate through the earth, how shaking varies across the region, what controls shaking in an urban setting, for example, if you're on rock versus soil, and the big picture tectonics, the understanding of subduction earthquakes, the understanding of earthquakes off of Haida Gwaii, and where other earthquakes might occur in British Columbia that, you know, where are the active faults? So there are a lot of outstanding questions and a lot of ongoing research, and much of it is, well, Andrew's leading a lot of this ongoing research in Haida Gwaii and the Arctic and Yukon. It's all new. And we also learn from earthquakes around the world, from earthquakes in Chile and Japan. We take data from those countries and apply it here in our region as well. So a lot of studies underway, and it's a science that's evolving very, very rapidly. And probably the best example is when I was a graduate student at UBC 30 years ago, we didn't know about the magnitude 9 earthquakes. So we didn't know that those earthquakes occurred here. And if you don't know about something, you can't prepare for it. So now, and it took decades to really accomplish this science, and it took many people working in many fields. Now we know where the energy is being stored. We know how often those earthquakes occur. We know when the last one struck, and we can generate models of what to expect in terms of ground shaking and movement, both vertical and horizontal movements that will take place at the time of the next magnitude 9. So it's a science that really is evolving so very quickly, and you know, we have some very talented young scientists, many in our organization, I'll let Andrew talk about this, that is really cutting edge science. What's going on?
Yeah, in an area like BC, where there's a lot of remote regions, a lot of places haven't seen instruments, and so you don't have to go very far to put a new instrument down, and all of a sudden you're getting potentially new fundamental insights about a region. Even Victoria, it was only a number of years ago that the Leech River Fault became a bit more active discussion. With the discovery of this active piece of fault in the strait in U.S. waters, and lo and behold, it continues. Questions still about whether it's actually active or not, and there's still ongoing debate in the scientific community about the activity of that fault. It's not the only one in Southwest BC. That even in an area where we're living and working here, there's still lots of questions to be answered. And so, as John said, rapidly evolving, and in this case, it feeds right back into things that matter, like building codes that have big impacts when a large earthquake like this can actually happen.
I think this is the value of research and the value of Canadian-based research, that we're really studying in our own backyard. Certainly we can learn from our colleagues around the world, but nothing beats studying right here and chatting with our elders and Indigenous communities and hearing those firsthand stories of their experiences and what they've heard that passed down through generations. So such value in that. We've got just maybe 2 minutes here left, and I just want to ask one last question here from Jocelyn. She's wondering about the risk of tsunami in coastal Vancouver and the Lower Mainland, and what the risk of tsunami is in that area.
Well, a lot of people think that Vancouver Island is shielding them, and they're correct in some respect. I mean, certainly the main part of the megathrust area is off the west coast of Vancouver Island. Some of that, however, will make its way around into the Strait of Georgia and that area. I'm just talking about the Cascadia subduction zone event here, and in that area, it's not going to be huge inundation, but there's going to be some flooding in low-lying areas. And what's going to be really dangerous is the fact that these are going to be very erratic, very strong currents. I've seen footage of a very low tsunami coming into an area. It looks quite innocuous, but it hits a marina, and all of a sudden the docks and the boats are just being tossed around. I mean, they're really very powerful events. The other thing that can occur, as we were talking about earlier, is if you have, say, a magnitude 7 earthquake in the Georgia Strait region, and it triggers an underwater or coastal landslide, and that can create a localized tsunami in those inland waterways. So it's always good, to just keep that in your mind and know where to go. Think about where you work, where you live, where you play. Are those places in tsunami inundation zones? Do you need to think about where you would go in the case of a large earthquake?
And if you aren't sure if you live in an inundation zone, your local authority can share that information. Yes. So the municipality that you live in, the regional district that you live in, that's information that will be available on their website. They all have an emergency preparedness section on their website. I encourage you to look out for that. The other thing that's important to do is to sign up for those alerts. And you can do that through your, through your local authority. So no matter what the emergency is or hazard that might be occurring in your region, you'll get an alert to your phone, or sometimes they do robocalls to your home. If you still have a landline, you'll get a robocall or a text depending on the municipality. So that's one more piece of that emergency preparedness and awareness puzzle. Any final thoughts from our seismologists here, or from Michelle, or from Marc?
I guess one minor thing. Lots of us have managed to now spend quite a bit of time in our homes the last while. So we should all have a firm idea of, no matter which room we're in and an earthquake happens, where we're going to go as part of our exercise tomorrow.
Absolutely. So on that, that's the perfect segue, Andrew. Tomorrow is ShakeOut. If you are not yet registered, please go to shakeoutbc.ca/register and sign up. And you can practice your drop, cover, and hold on. All of us are going to be doing that tomorrow. So I want to say thank you all very much to our panelists for joining us. For those that have joined us online, thank you so much. We will make this link available and you'll get it from me via email. So thank you and happy ShakeOut.
Bye, everyone.
Thanks. Bye-bye.
Happy
Bye,
ShakeOut.
thank you.